Hello class, in this video we're gonna learn about wood. So before we start a lesson, I want you to pause the video and let's look up online to see if you can find the difference between timber and lumber, and then look it up a little bit before you continue with the video. After you search online, you can see a lot of discussion about the difference between the two. A lot of websites discuss about that. And I want to introduce to you one source that called AWC. That stands for American Wood Council. The American Wood Council over here, they publish a lots of data about the strength of wood material, especially for construction. So we can use that in the construction structure design, also inspection and checking for the structure as well. And based on their classification, they decide that any piece of wood that have the smallest dimension. For example, if you have the piece of wood over here, normally we have two dimension over here. This one is one dimension. The other dimension is over here is dimension 2. And you see sometimes they call this one is the thickness of the wood. Sometimes they call this one is the width. And from here to here they call the length. But I just want to call this one is the smallest dimension. And they say if the smallest dimension is smaller than 2 inches, you want to have that one is a bore. If anything from 2 to 4, you're gonna call that one lumber. And if you have anything larger or equal than 5, you're gonna have timber. For example, I have over here this piece of wood is 2 by 4. What is the type of wood of 2 by 4? So if you have 2 by 4 2 by 4 here, the smallest dimension is 2 inches. So that one is a lumber. So you see that lumber. Okay. What about if I have 1 by 12? What is that? So the smallest dimension of this one is 1 inches. So if that one is 1 inches, the types of wood is that one is a bore. Not difficult, right? How about if I have 4 by 5? What is that? The smallest dimension is 4. So that one is a lumber. Okay. If I have 6 by 5, the smallest dimension will be 5. And that one is, because it's 5, that one is a timber. Okay. Not difficult, right? All right. So the next thing I want to show you is the nominal dimension and the actual dimension. So the piece of wood I have over here is 2 by 4. So what is the thickness of the wood and what is the width of the wood? I want you to pause the video and think about it. So normally if I say this one is 2 by 4 wood, you're gonna think this one is 2, this one is 4, right? However, when you measure that, you can see over here the thickness of this one instead of 2 is only 1.5 inches, and the width of this one instead of 4 is only 3.5 inches. Okay, you can see this one is 1.5 and this one is 3.5 inches. Why we have that happen? That one is because we have 2 by 4 is the nominal size, and we have the actual size as well. So 2 by 4 is just a nominal size. If you want to find the actual size, you can go to my reference over here, and you can open the American Wood Council here. You go all the way down here, you can see that 2 by 4 wood will have the size is actually 1.5 by 3.5. Okay, so keep in mind that the name of that is represent the nominal size. The actual size usually short up from 0.5 to 0.75 inches. For example, you have 1 by 12. That one is 3/4 by 11.25 inches. Okay, so you need to go to the American Wood Council reference over here to check the actual size. Next one, we have the edgewise and flashwise use. You can think about edgewise is the strong direction and the flashwise is the weak direction. However, sometimes like if we need to use the wood piece for the slab, for example, like that, we do need to use the flashwise use and use for the weak direction. If you review my video on steel, you already learned about that, but let me review one more time. So if I bend the wood around the width of that one over here, if I bend that in this direction, it is very hard to bend. It will be harder to bend. Okay. However, if I bend in this direction, in the flashwise use, it will still hard for me because this one is very big. You can see. However, that one is will be used. It will require less forces to bend this one. So this one we're gonna call that one is a flashwise use, and this one we're gonna call that one is the edgewise. So this one is a force applied to the edge of that. You can think this, or you can call this one is the strong direction, and this one is the weak direction. And just want to review this one more time because we're gonna use that again in the worksheet. You're gonna find for me the strong section modulus and then the weak section modulus. The strong section modulus normally is Sx, which is the one have a higher value. Like I mentioned previously, that if we have higher section modulus, higher moment of inertia, we're gonna have a stronger material, or that one indicate a strong direction. Okay, so the bigger number of this one will be the better the material is.